we are mainly focusing on what are called cyclic quadrilaterals. Okay? Now, as you are aware, a quadrilateral is any four-sided shape. Okay? Any four-sided shape is called a quadrilateral. Now, you mustn't worry about the name of the part. Okay? Because some of the quadrilaterals that you are going to encounter in psychogeometry, they don't have a specific name. Okay? Like how we were taught in grade 9 and in grade 10. So a quadrilateral whose vertices are on the circumference of a circle, like in this case, we have got vertex A, vertex B, vertex C, vertex D on the circumference. Okay? So those four vertices are on the circumference. Therefore, the quadrilateral has got a special name. Okay? It is called a cyclic quadrilateral because it is inside the circle and its four vertices are on the circumference of the circle. Right? Now, cyclic quads have got their own theorems. So let's move on to theorem 5. Okay? Now, theorem 5 is the first theorem of the two theorems on cyclic quads. There are only two theorems on cyclic quads. Okay? Now, this theorem here, it is also examinable, like theorem 1, theorem 2. This is the third theorem, which is also examinable, which means it can come in the examination. The proof can come in the examination. Right? Now, according to theorem 5, the opposite angles of a cyclic quad are supplementary, which means they add up to 180 degrees. The opposite angles of a cyclic quadrilateral are supplementary, which means they can add up to 180 degrees. Right? So the acceptable reason based on the examination guidelines, I gave you a copy, okay, is that one. You just write OPP, then you put angles, then cyclic quad. So this is the acceptable reason. The opposite angles of a cyclic quad are supplementary. The shortcut in terms of reason, you just write the one which I highlighted, I underlined underneath. Okay. Okay, just do me a favor, just put your pen down a little bit. I need to talk about the proof now. Just put your pen down. I'll give you an opportunity to copy this down. So, to do the proof, we use theorem 2. Theorem 2 is like the mother of theorem 3, theorem 4, theorem 5. Okay? So we use theorem 2 to prove that the opposite angles of a cyclic quad are supplementary. So, you'll be given, if you're asked to do the proof, you'll be given 4 points on the circumference, A, B, C, D, okay? Then you need to do some kind of construction for you to prove that angle A plus angle C is equal to 180, or angle D plus angle B is equal to 180 degrees. You will need to do some kind of construction. So you construct two radii, that is OA and OC. So you join A to O to create radii AO, also join C to O to create radii OC. At the same time, at the circumference, you have to mark that obtuse angle as O1 and the reflex as O2. Okay? Once you do that, it's also important for you to know that here, we are only going to prove that based on the diagram, angle D plus angle B is equal to 180 degrees. So this obtuse angle, it is 2 times angle D. So we say O1 is equal to 2 times angle D. That's angle at center is 2 times angle at the circumference. Also, the reflex, which is O2, is 2 times angle B. Okay, please take note there. The reflex O2 is 2 times angle B. So, right, O2 is equal to 2B, right? But we know, based on what I told you, I think I told you before about this, when I did the proof of theorem 2, that sometimes in maths, especially in geometry, if you have two equations, you can add their left-hand sides and their right-hand sides simultaneously. So if I add the first equation and the second equation, I'll get O1 plus O2 is equal to 2D plus 2B. Then on the right hand side, use your knowledge of factorization from algebra. If you factor out 2, okay, you will get this. Okay? But O1 plus O2, they add up to 360 degrees. Because they are angles around a what? A point. So we have got that in the reason. Because the sum of O1 and O2 is equal to 360, and because 2D plus 2B can be written as 2 times angle D plus angle B or vice versa, we can divide both sides by 2. So if I divide both sides by 2 in this equation here, I'll come to that equation. Which means indeed, angle D plus angle B is what? Is equal to 180 degrees. If you want to prove that angle A plus angle C add up to 180, you construct 2 radii from O to D, another one from O to what? To B. That will be a different orientation now, okay, in terms of which opposite angles, which pair of opposite angles you want to prove that they are equal to, so that their sum adds up to 180 degrees. All right, so that's it. So this proof, it comes in examinations, okay? When you write your junior examination, there is going to be a proof, okay, on circle geometry. Either to be theorem 1, theorem 2, theorem 5. We have got a fourth theorem, which we'll talk about later under tangents. Okay, so let an interior opposite angle. An exterior angle of a cyclic quadrilateral is equal to an interior opposite angle. For our diagram, C1 will be equal to angle A. So C1 will be equal to angle A. And that originates from the fact that angle C2 is related to both C1 and angle A from these two equations. So angle C2 plus A will give you 180. Angle C2 plus C1 will also give you 180 degrees. So C2 becomes a common angle. Therefore, we can equate, since the right-hand sides are equal, we can equate the left-hand sides, and the C2 is going to cancel out, and you are going to be left with C1 equal to A. Okay, just to emphasize what I'm saying here. Since the right-hand sides are equal of those two equations, therefore means the left-hand sides are equal. So C2 plus angle A will be equal to C2 plus angle C1. Now, you can take C2 to either side. You'll be left with angle A being equal to, so this C2 is cancelled out. You end up having angle A equal to C1. So an exterior angle of any cyclic quadrilateral is always equal to an interior opposite angle. And the acceptable reason, you just write exterior angle of cyclic quad. Okay? The acceptable reason, you just write exterior angle of cyclic quad. Okay? Make sure you pay attention because this part, it causes lots of problems. Make sure you pay attention. Alright. Now, it's very important for you to know how to prove that a quadrilateral is cyclic. Now, to do that, there are 3 ways. 3 ways. First, if you can prove that the opposite sides, or rather opposite angles of a quadrilateral add up to 180, then you can conclude that the quadrilateral is cyclic.
So do you have to use both sides or
Okay,
one?
for now, okay, generally you just have to choose any pair of opposite angles. Any pair of opposite angles. So if you have got a quadrilateral, if you can prove that the opposite angles add up to 180, you can conclude that therefore the quadrilateral is cyclic. So that's number 1. Okay? So that's the first way to prove that a quadrilateral is cyclic. Another way is to prove that an exterior angle of the quadrilateral, because in this case you won't be told that the quadrilateral is cyclic, and sometimes it won't be inside a circle, it can be outside, or it can be inside the circle but the vertices won't be on the circumference. Okay, so if you identify an exterior angle, and if that exterior angle is equal to an interior opposite angle, then you can conclude that therefore the quadrilateral is cyclic. Your reason will be converse exterior angle of cyclic quad. For the first condition, your reason will be converse opposite angles of cyclic quad. If you are proving that a quad is cyclic. Don't worry, tomorrow we are going to do a question like that. Okay? So we've got the first case, converse opposite angles of a cyclic quad, which is the converse of theorem 5, which I asked you to go home and draw a diagram of and write its statement. Then theorem 2, if you can prove that an exterior angle of a quad is equal to an interior opposite angle, then you can give your reason that the quadrilateral is cyclic because of the converse of the exterior angle of a cyclic quad. Then, condition 4, you can use the converse of theorem 4. The converse of theorem 4, so if you can prove that there is a butterfly, if you see a butterfly, like in this case here, okay, so we have got a butterfly there. So if you can prove that, angle A1 is equal to angle D1, if you prove that those two are equal, then you can conclude that therefore A, B, C, D is a cyclic quad, and your reason will be converse angles in the same segment. Please take note, the word converse is very important when you are proving that a quad is cyclic, or when you are proving the opposite of a theorem, whether a line is a diameter or whether a quadrilateral is cyclic. Later we are going to talk about tangent theorems. There is the famous Stanford theorem. Whether you want to prove that a line is a tangent, you use the converse. And the first word that you have to write is converse. Then you state the original theorem. Okay, so there are 3 ways. Okay, it's not that challenging, but from my experience, you learners, you make it a bit challenging. You need to know where to start. So with proving that quadrilaterals are cyclic, you have to know that there are 3 ways. So you can use elimination, the elimination method. Identify if there's a butterfly. If it's not there, you throw away condition 3. Identify if there is an exterior angle of the quadrilateral. If it's there, then you might need to use it. If it's not there, you throw away condition 2. If the opposite angles can add up to 180 degrees, then you use condition 1. If the angles cannot add up to 180 degrees, means either you might have to use condition 2 or condition 3. So it will depend with the question. Okay.